Now we begin the last part of this webinar. After detecting structures and particles, after refining the detection, and after classifying particles based on a combination of parameters, we will now show you how to perform statistical analysis on those results. Before digging into the detail, let me show you what to expect. I have prepared a document right here, a similar document on the exact same surface. The idea of those statistical analyses is to calculate, for instance, and summarize averages, display distribution, particle versus number of particles versus certain parameters, to compare classes, number of particles belonging to different classes, display scatter plots, see if there is a correlation between one parameter and the other, calculate or display control charts, so variation of a single parameter from particle to particle, maybe in a controlled process environment for passive N tests, and box plot for comparing, again, in between classes or for comparing one sample to another. So let's build these statistics. Now, all of those things have been nicely placed together into the results tab here. And we will mainly focus on this part, statistic over results. We can start with the statistical summary. And you will see that each time we select a new statistical analysis, there's a trend. The software first asks you what kind of parameters you want to display, and if you want to calculate, those on all of the particles, or using a classification, or using a single class. So for now, we could calculate, for instance, these parameters, or maybe not. Let's take this one out. You might want to calculate the mean, the standard deviation, and maybe the range. And you see that each time I'm changing something here, the results here are being updated. If you want to calculate then the average of the projected area, volume, and skeleton length on all of the particles, you do it simply like that. Now, if you want to limit the scope of this statistic to a certain classification or certain classes, you can go back here, select results, and then you will either select the three classes belonging to this classification, or maybe just the first one, and the software show you on how many particles are taking into account over all of them. When you are happy with your selection, you click on OK. When using classification and classes, you might want to display those information directly on the table, and you can do that by clicking here, filters. You see, you have the information of the classification used, and on a single class being selected, and the number of particles on which those statistics are being calculated. The next item on the list will be the histogram. Here you have the list of all of the parameters that were calculated, actually the first 4, and then the 2 classifications that were designed. So let's first select one of these, the volume. And if you change, basically, if you change the parameter calculated, you see here the result being updated. Of course, you will have a different distribution when you go from skeleton length from to projected area. When you are happy with the results, you click on OK. If I press F11 for full screen mode, here's how you can modify the outline, the number of bars. Right here, bin settings. Then you can increase from 28 to 50, for instance. Or you can go back to being automatic. You might want also to, again, use a specific classification, for instance, these, like that. Or you might want to display the proportion of each classes in a single classification. If I'm selecting the fiber length, I have 3 different classes. And in here, you have the proportion of each classes in the classification. You have, for instance, roughly 170 particles in the short class. Then you have roughly 15 in the medium and roughly 5 in the long one. Next up is the control chart. The idea behind the control chart is to look at a single parameter, such as the Zmax, for instance, and to plot its value from particle to particle. And here is the result. Each point corresponds to a particle. And it's you can use the control chart to see if you have a lot of variation of the value for a certain parameter. You could also have a display standard deviation, calculate or display the mean line. But if you want to strictly control the value of your particle or your structures for control process application or something else, you can display and set up upper control or lower control limits. So the lower could be something like 1 nanometer. The upper could be 3 nanometer. And you have this line here. And the yield is an expression of how many of these points are in between the control limit that we have set up. These can also take into account different classification, as you can see. And you can color those points based also on the classification right here. You can have the projected area and also the fiber length. Next is the scatter plot. You will find it in the results tab as well, right here. The idea behind the scatter plot is to see if there is a correlation between one parameter and the other. Let's put it in full screen mode first. We can go back here to recall a selection of the parameters. Now you can select, for instance, the project area on the y-axis, on the x-axis, and the skeleton length on the y-axis. Each point corresponds to a particle, its coordinate being its value for the projected area and the skeleton length. Again, you can fairly easily change the parameter used, but you can also limit the scope of calculation with these classification and these classes. And the software will also show you directly on the scatter plot the color. So you can see that these here correspond to class A, the green to class B, and the blue to class C. Also, in the scatter plot, you can calculate, display and calculate the regression line and the corresponding components, which give you also an indication of whether you have a good correlation between one parameter and the other. The last item in the results tab that I would like to show you today is the box plot. The box plot is another way to easily compare values, or not values, but distribution of values between classes or between samples. In that case here, we will be comparing parameters distribution inside a single class. So you first select your class like that. Then on the vertical axis, you will select the parameter you want to track. We can put the volume, for instance. You click on OK. And if I display the box plot in full screen, here's what you will see. It's almost like looking at a distribution from above. These 2 points here are the limits of the distribution. The solid line is the median. The cross is the average. And the lower and the upper boundary of the box plot are the quartile.